Good evening, Agent. Your mission, should you choose to accept it, is to develop a cracking tool to gain access to the vault of our next target. The prior agent who was working on this was captured by a rural organization while running a surveillance op on that target. However, his work in progress code is available for you to use. We expect you to use this skeleton code to continue development and finish what he started. As always, should you be caught, the Secretary will disavow any knowledge of your action. This paper will self-destruct in 5 seconds. Welcome to Assignment 2. In Assignment 2, you are going to be working on a project that is going to test your skills in using classes. For that, I'm going to go ahead and walk you through the assignment PDF, and then I'm going to show you some examples of the code running. So let's get started, shall we? Okay, so here's our assignment PDF, and there's that little message that I read you just to kind of get you in the mood for the assignment. And so this assignment is hacking themed per se, but there's very little hacking you're doing. It's just to make it a little bit fun, and there are some memes on the PDF that you can enjoy. So basically, you're going to be working on 4 main files, and those files are going to be main.cpp. Well, there's 4 files, but actually you're working on 3 of them, because main.cpp you're not touching. Assignment 2.cpp, jackie.cpp, and jackie.h you are going to be modifying. So with that said, I think I'm going to give you an overview of each of the files, but first I'd like to just kind of give you an overall overview of the assignment per se. So I encourage you to read the PDF first and then check out this video, or pause the video and look at the PDF, because I can't cover everything in the PDF in the video because it would just be repetitive at this point. I kind of want the video to enhance the PDF. So there's 3 vaults that you're going to be opening per se, and the vaults are a key code vault where you have numbers from 0 to 999, and there's a secret value to open it, and that value is randomly generated. So it could be 1, or it could be 999, it could be 0, it could be anything in between. The way you're going to break that vault is you'll have a function that just basically linearly tries every number from 0 to 999 and eventually figures it out. The second vault is a little bit more complicated, and for that I kind of want to show you a picture. So the second vault is actually a 2-dimensional array of booleans, which I will refer to as zeros and ones. And so actually, it's mostly zeros. In fact, every single spot in the array will be 0 except for 1, and that spot will be also randomly generated. So for example, let's say that spot right there is the one that's set at 1. So in order to unlock this vault, you're going to have 2 indice variables which are called index 1 and 2. Index 1 handles the vertical and index 2 handles the horizontal. And you can think of it like a coordinate system in which the top left is going to be your 0, 0. And the bottom right is going to be, well, I guess 99, not 10, 10 is going to be your biggest value. So if you're going down, that first value of index 1 increases. If you're going up, it's decreasing. Whereas for going left and right, if you're going right, it increases the second value, the y coordinate per se. Well, I guess that's different than x and y inverted, I suppose. But yeah, so the second index increases as you go right, and if you go left, it decreases. So in other words, if we're looking at, say, this spot right here, that spot would actually be 0, 1, 2, 3, 0, 1, 2, 3, yep. And then spot 0 for the second one. So index 1 would be 3, index 2 would be 0. Now as for the 1, where is that located? Well, let's see, 4, 5, 6. So it's 6, and then it's 0, 1, 2, 3, 4, 5. So this will be at 6, 5. Okay? However, you're not trying to guess the index by just brute forcing it like the previous key, because in this case you cannot interact directly with those index or indices. And that's by design, because I want to show you that with object-oriented programming and information hiding, you don't always want to interact with specific variables. So in this case, the way you interact with this vault is with couple of functions that are called move up, down, left, and right. And as the name implies, what they do is every time you call one of these functions, they're going to move the location of those index. It's only going to move one of them at a time, and move up is going to affect index 1, whereas move down will also affect index 1, but move left and right will affect index 2 because those move horizontally. So you're never modifying more than one index per function. And so again, it might be a little bit unintuitive, but when you move down, you're actually increasing index 1 because of the way that the coordinates are set up. So that's a little bit unintuitive, right? So in the case of moving up, you are actually decreasing, and moving down, you're increasing index 1. Okay? So that's, you can think of it like little knobs that you're turning to get to the right spot to open the vault. And so that's the second vault. And finally, the last vault is going to be very similar to the first vault, which is just going to be a key code with a slight twist to it, which is going to be that you can only try a certain number of times. Okay? So, before I get to show you the code, I want to show you a little bit about the classes that you're working on. So, the first class I want to point out is the lock map. The lock map is the map version of the vault, the second one. And so, index 1 and 2, we already know what they are. The M is just the array. That's the array of booleans, and it's always of size 10. So indices 0 through 9, both for the first and second coordinates. And so you got a couple of functions for that, which I've kind of gone over, the move up, down, left, and right. The check function does not take any parameters because all it's going to do is it's going to look at the current spot in index 1 and 2 and see if that is actually the correct spot in the vault. If it is, it will return true. If it's not, it will return false. The reason it's a const is because it's only checking, it's not modifying everything, whereas move up is modifying the index values. The constructor is going to initialize the array in terms of randomly selecting one of the spots to be the one that opens the vault. Again, we don't want to know what that is because that's the fun, right? We're trying to figure it out, we're trying to crack it, so we don't know what the solution is. And we can't access it because we don't have access to the private variable, right? So that's how that works. Looking at lock code, that's the easiest version of the vault, and that one is a very straightforward function. You have the code variable, which is going to be randomly generated, which has the solution, and check code is going to pass in as the integer the code you want to check and it's going to compare it versus the code that it has and see if they match. It returns true. If they don't, it returns false. The constructor also going to randomly initialize that variable so that we always have a different value for the solution, and then we can see if our cracking will work. Lock code v2 is that variation of lock code, the vault 3, where you are limited in the number of attempts. And so that's kept there in that attempt variable. So that variable will be this is how I hard coded it. I want you to also hard code it to be 3. So it's going to always start at 3. And so that means that you only get 3 tries. Now, whereas with the first vault, we are just linearly trying every number like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because you're only getting a limited number of attempts, if you just tried linearly, you would all be just trying the same ones, and that doesn't seem very smart. Well, what I'm doing is not very smart either, but it seemed a little funner. So in this case, for this vault, we're going to decrease the number of what the code can be. So on the first vault, it's from 0 to 999, so basically 1,000 combinations. For this one, we're only making it 10, so 0 to 9. And for that, we can only attempt 3 of those. So we can only attempt 3. So we can always attempt 0, 1, and 2, I guess. But to make it fun, instead, all 3 attempts have to be random guesses. So every time you guess, it's going to be a randomly generated number to take the guess and see if it matches. So in theory, some cases you will guess the right answer and the vault will open. In other ones, it will not. In fact, statistically speaking, you will more than likely, the majority of our cases are not going to unlock this vault. It's only in that 30% of the cases, I suppose. So like less than a third, you're actually going to open it. So there's output for both cases as well. So that way, don't freak out if the vault doesn't open. Your code is not necessarily not working. It's just that specific randomness didn't open the vault because you picked the wrong numbers. You guessed the wrong numbers, right? It's like a lottery, right? So except this lottery is about 30% chance of winning versus really low for the real lottery. So that's how a lock code to V2 works, okay? Now I want to revisit this picture that you might have briefly seen. So we are going to have a function or actually here, yeah, let's go to this function. So now let's go back to this function, or this, sorry, function, class. So the hacker class. So the hacker class is going to be just a bunch of functions, and they're all static, and then you also have a static variable. And the job of the hacker class is essentially that tool you're developing to crack these vaults. And each of those functions is designed to crack one of the vaults that I mentioned. The first one there, the crack code lock code, is going to be that 0 to 1000 combinations linearly. The second one, crack map, is that 2D array. And then the final one is the one with the 3 attempts only. So let's kind of look at the lock map one. So that's the only one, because I mean, for the one from 0 to 1000, I told you just go linearly. It's a for loop, you're good. For the other one, you're taking a guess each time, and you're comparing the guess with the right code. And every time that you guess something, every time the function is running check code, because we have a check code function here. So every time this check code function runs, it's going to decrease the attempts left by 1. So it's going to go 3, 2, 1, 0. So once it hits 0, it doesn't matter if you put in the right code, it's not even going to compare it. If you do happen to put the right code before you reach 0, it should reset to 3. But of course, at that point, you open the vault, so it doesn't matter, right? But still reset it, because I think that's part of the output that I have set. So yeah, so the tricky one is going to be probably the lock map for everybody. So that's the one that I kind of want to explain. So because we are grading this automatically with codegrade, we want to make sure that every time there's something random, we want to make sure the random matches, your random is the same as my random. And how do we do that? We feed it the same seed value. But even if we do that, if you call random a different amount of times than we do, or in different order, your random will still be different than the solution, and then the grading will not work. So I had to take special attention to make sure that I called random as few amount of times as possible, and that I clearly define in the PDF every single time that random is called, so that you do the exact same ones, so the code matches the solution when it's doing the comparisons, and you get your full grade. If they don't match, you will not get your full grade, because that means you changed something the way that I did it, and you got to figure out how to do that. So that's why I will overemphasize all of those situations, even in the video probably later, but definitely in the PDF. I believe it's 4 of them, and they're very clearly defined. The majority of them, you are actually already given the skeleton code. I think the one exception is going to be this guess function. So let's take a look at that. So when you're trying to crack this 2D array vault, again, you cannot just try indices. You have to use the move functions. So you have to pick a pattern on how you're going to search through this. It's still, in a way, a linear search per se. You're not doing anything fancy. You're not randomly picking stuff. You're doing it linearly. But rather than it being a straight up and down thing, what I decided to do to make it fun is you have this little spiral that you're doing. So when you start at the top right, you're going to go all the way to the left on the first row, and then you're going to go down by 1, check that bottom one, and then go backwards to the first one, and then down and backwards. So just to make sure that we're all on the same page, let me actually draw an example of that. So you're going to start here, and you're going to check all of these, and when you finish this one, you're going to hit the edge here. So you're going to go down 1, you're going to check that, and then you're going to go this way, check all of those as you go. When you get here, you're going to go down, check that, check, here, go down 1, check that, and so on. And you're going to keep doing this over and over again until, well, I guess I kind of skipped it, until you hit either the end of the array. But what's going to end up happening, because all of these actually have solutions, except for the vault with the attempt limitation, is you're going to hit the 1, and then you're going to be done. So I guess that would be when it would stop. And then you can say you cracked the vault, because, well, you get true back from the check function. The check function is going to be this one, which you can see does not have any parameters. All it's doing is it's checking the current indices, and if that returns true, then you've cracked the vault, or you hacked the vault, I suppose. I really wanted to call it crack the vault, but I did an assignment like that a long time ago for a different topic, so I don't want to have matching assignment names to things I've done in the past. So yeah, that's pretty much it from a context, like the concept point of view. So now what I want to do is go over a little bit of the code. So again, you are only going to be writing code where it says your code here. And I do have skeleton code for you, and you can only modify the sections that you're allowed to modify. I said basically where it says your code here. You can't change my code. In fact, I would say you cannot even modify. You cannot change my code. You can only add code, and you can only add it in the locations listed. And that is supposed to train you to get used to the idea that when you're working in a project, even though you're working on this on your own, and yes, you should, but when you're working on a project, you have to handle the limitations of the code given to you, which part of most of the job is just learning the code, understanding how to use the existing code base, and then be able to fix things with it or add things. In our case, you don't need to fix anything because I think my code is good, fingers crossed. But you do definitely have to add code to finish it, essentially. So what I did when I did this is I solved it, got everything working, good to go, and then I deleted some code and said, this is what you're going to code. So that's how I did the assignment. Probably took me longer to make the assignment than it will be for you to do the assignment, because this is a pretty easy assignment in my opinion. Easier than assignment 1 probably. So the idea is, again, this assignment is going to sort of get you ready and comfortable for the next assignment, where you're really going to be doing some cool stuff with classes, and it's going to be a more thorough assignment. So this assignment is really there to kind of warm you up to using object-oriented programming, classes, and writing skeleton code, or writing with skeleton code that already exists versus writing from scratch, which you might have done in a previous class, but we still wanted to sort of wean you into it. Okay, so main.tpp, I think for this, let's actually switch over to not that, but there we go. Okay, so let's actually just kind of look at the skeleton code. So, I mean, the PDF is basically going to explain the same thing that I'm explaining, but I think I'd rather do that while you're looking at the skeleton code, because that's something I couldn't do with the PDF. You know, it's like, unless I took a bunch of screenshots and little laser pointers. So the main.cpp file you're not modifying, but I still want to give you an overview of it. So you have command line arguments. You're passing in one argument, which is going to be the seed value. So the seed value defines so that the random is the same. If you don't pass any seed value, it defaults to 0, and there's no real cleanup of that seed value, so only feed the numbers, please. Okay, assignment 2. So and the function is going to call assignment 2 function. So this here is going to be the assignment 2 function. Okay. Or sorry, well, yeah, this is the assignment 2 function, but there's also other things here. So let's just kind of go over from the top. So you're including this so that the code can compile with just g++ main versus g++ main, and then also having to put jackie.cpp in it. And you need to put up here, this is the first spot that you really need to code, is you need to code the class, the declaration for the hacker class here. Okay? And then beneath it here, you're going to put your definitions. So you're doing one file for class declaration and definitions. Okay. The only time that you do inline class definitions within the class declaration is for the constructors. Everything else should be outside the class. So you're going to put that in here. And what that is going to look like is going to be the 3 functions: the crack code for the lock code, the crack map for the lock map, and the crack code for lock code v2. So there will be here 3 functions, and at the fear of, okay, so I also have the solution here. So now I'm looking at the solution, and yes, there's just 3 functions. Okay. The important thing to point out again is going to be in the crack code lock code version 2. You want to make sure that one has a random guess in it, so you're guessing what the value is, and you want to make sure for that one that you use this exact code here: int guess rand mod 10, and it's going to be part of your for loop. That in this case it's running 10 times, but really we know that after the 3rd attempt it's going to lock you out, but you still want to run it 10 times because that will produce output, and you want to match the output. Okay, that's the only trick with that function. So that's pretty much all there's to that. As for the assignment 2 function itself, I believe there's only one line that you need to put in here. And that's because I really wanted you to have a instantiation of an object, or for a class, sorry, by making an object. And like this, basically this. So this is like the easiest line in the world. Should take you 2 seconds to do it, but I still wanted you to do it. So there you go. That's all you gotta do for this file. Again, mostly just your hacker stuff. Looking at the CPP and header file, let's first look at the header file actually. So the header file is going to include 3 classes in it. And that's going to be the class for lockmap, as you see here, lockcode, and then lockcode v2. As you see, you're already given lockcode v2, so that's done, so you don't need to touch that, and you shouldn't touch that. Lockmap, you're partially given that, but there's missing a bunch of functions you got to put in here, so refer to the UML diagram for that. And you're missing the 2 variables here, I believe, for the index 1 and index 2. Refer to the UML diagram for that as well. Lockcode v2, you need a code, and you are referencing it here, so you can see how that's done in that. And there's also a function already done for you here for check code. So yeah, but you're only putting the declaration here, so you gotta make sure everything kind of works out, because this is already written, so this must interact correctly with this and compile. So again, the only little typo, I'm not fixing that, but that should say make. But make sure your constructor here has this line of code. You can see what that line of code also looks like here. Let's see where that is. Right here. So you gotta make sure the constructor is in this format, because that's how I generate the random spot in the array. That is 1 that you need to then find out. So make sure you use that just like that. So yeah, put the constructor in and create the class there, and you're good to go. That's all there's to it for that file. So here you're going to be putting all the definitions. The list of those is in the PDF. So this is the ones. As you see, I'm giving you 3 of them already, and then the other ones you have to do. This is very easy, especially once you see how this is done. The move up, the move button, left and right should be like done. The check code, you can use this one, and it's basically a simpler version of that. So also a piece of cake. This should be a very straightforward assignment. So like I said, it probably took me longer to make than for you to do, and that's fine. So yeah, you can see here that the way this works is you check for how many attempts you have, and if you don't, then you're done. And then basically you're just taking this is some safety to make sure you're not feeding invalid data. So you want to always check, so you don't basically have weird numbers that don't make sense, because you can only go from 0 to 9. And then you can see that it resets the attempts to 3 if you do get the right value, and it returns true if you get it right. If not, you get it wrong, and you decrease this. Move up, you can see how it works. You're basically just checking to make sure you're not going out of bounds in the array, and then you are decreasing the index or increasing it in the other cases. 2 cases you increase, 2 cases you decrease. So just do that. And you already have the check function here, so you don't need to do that one. So that's pretty much it. I think the only other thing that I wanted to mention is that, again, sometimes you will get this solved, sometimes you won't, because it's not going to always crack this vault. So just keep that in mind. And let's go ahead and look at the output and just see what that looks like. I think we should be good to go. So here is the output. Let's just run it again. So I'm going to run it with actually just the default. Okay, so the default, no value passed in. Okay, all right, let's compile first. How about that? Oh, it's not gonna compile because I'm using the skeleton code. Ooh, okay. Give me 1 second to restore the code, actually. I was wondering why I had that a.out file in there, actually. So replace, and now hide this so you don't see the solution. And then, okay, we're good. So, all right, so now we should be able to see it. Let's just test it compiling. I'm gonna recompile again. So let's do with the default, and as we can see, let's go from the top. So first it has about message saying it's vault 1, and then it starts from 0. Make sure you watch this in HD so you can read that. And then just tries everything linearly until the solution, which is number 383. So once it attempts that, we get a message saying code cracked. Good. Second vault, as you can see, it's going to go in that zigzag. So first it's just going to move left. Moving left. I think I might have flipped the left and rights. Yeah, I think I might have, because I guess technically it should be moving right, not left. I'm left-handed. So you might have to flip that in your output to match mine. I may fix that before pushing the assignment. So just compare it with codegrade. And then if you gotta flip left and right, just flip it and we're good. But yeah, I think that's technically flipped. But yeah, move left, move down, move right. So yeah, it's still zigzag. It's just inverted the zigzag. And I think that's strictly my my left and right printing that is flipped. Not the actual code, but it's fine. If it's flipped, just flip it so it matches mine. So anyways, you zigzag down, and then you can see that once it finally finds it, then, or actually, you know what? It could be just that it's just checking, going down. So yeah, I'll have to take a look at that. But yeah, once it finds the location, then you can see it says cracked. And then finally for vault 3, it's going to attempt, and then well, technically, vault 3 runs twice. So there's 2 objects of that class, and you can see that in assignment2.cpp assignment2 function. And so that actually lowers the probabilities from 30% to 15, actually, now that I think about it. So, because it's 30 of 30, right? So, yeah. Well, 30 of 30 then it's probably less, more like 10% then, actually. So, yeah. But essentially, it attempts a number, it attempts another number, and in this case, it actually cracks it on the second attempt. But then when it runs it again, you can see that it's attempting 10 times and it failed to crack it. And that's because it couldn't crack it twice. So there's a couple of numbers that I discovered that work for cracking it. One of them is 11. So let's take a look at that one. So with 11, we can see the first vault goes all the way to number 423. That's a cool number. And then from there, we got the vault. Again, it's going left, down, right. Interesting. And then we get the third vault. So it attempts 3, it attempts 5. 5 was the correct one. Attempts it again. Attempts 1 and gets it on the first try. Pretty impressive. And you can see that this one says mission accomplished, whereas the previous one said failed to crack. And something I do want to point out is that when you're doing the hacker class, there's this usage variable. What that usage variable is, it's going to increase by 1 every time that you run these functions, because it's like just keeps track of how many times you use it. So, just make sure you do that. And then the other thing I want to point out is that if you look at the code, and again, I can't show you that piece of code now because I have the solution, but if you look at assignment 2 function, and it's coded for you already, basically, every time that you open a vault and you get a success, it increases by 1. And at the bottom of that function, it checks to see if that value is basically 4. And if it's 4, it means that all 4 vaults were open, and that's how it decides what to print out. Again, that's because these functions here in Hacker are value returning. So they return 1 when it successfully opens a vault, returns a 0 when it doesn't open a vault. This is separate to the usage thing. That always increases regardless if it succeeds or not in opening the vault. So just keep that in mind so that your output matches mine in terms of the success messages, because these are adding 1 to that. And as you can see, there's 4 vaults. It's one of these, and 2 of these. So it's 1 plus 1 plus 1 plus 1, that's 4. So that's where that's coming from, okay? So that's pretty much it. Unfortunately, I didn't realize about the moving left and moving right thing, so I will double check that in my code and provide the correct sample outputs for that. But it's going to be basically the same concept that I gave you in terms of the zigzag. This is what I want to do. I want to make sure the zigzag is right. which means that it should be moving right and then left. But I gotta check that. So yeah, I'll put a comment on the video depending on what I do. But as always, just match code grade output and you should be fine regardless of which one it goes with. Okay? So this video is already long enough as it is. So I think that's where I will call it. And thank you for watching. I wish you the best of luck with the assignment. Good luck, agents. And I'll see you around in the next time. Don't forget to like, comment, and subscribe.